Okay. Now this numerical is almost the same as the previous one, except that a point load of 20 kilonewton meter has been spread as a UDL throughout. So almost the loads are same, but the pattern of loading has become different. So I think the reaction forces should be the same. So let us now start solving the problem. What is the first step that you have to do? So first is, okay, I think first step, it is the numerical which is given in the question paper. Will you draw the same thing?
No.
So you start drawing a free body diagram. You start drawing a free body diagram. So erase this. You call this as free body diagram, FBD, by erasing this. Erasing this and replacing it with a point loads. So here you replace with the point load. You convert this into FBD, free body diagram. So you call this as A, call this as B, call this as, so C is not required here. So you can call this as C, you can call this as D. Okay, now once you have done this, then what is the next step? So before that you should need to draw the lines here. So light lines. So you draw here and then reserve the place for SFD BMD and then start doing calculations here. So calculations, this is free body diagram. So let us, so should I take it as sigma MA is equal to 0? Is it right? Should I take? If you take moment about A is equal to 0, then you will have RB into 1 and this RD into 3, two unknowns in the equation which you can't solve. So you should take at one of the supports so that one of the support reactions are eliminated. You should take it at B, or if you want to take it at D also you can take, it's left to you. Okay, so take about B. So we will consider that anything which is actually about this point, anything which makes this beam rotate clockwise is positive. So these, so can you tell which are the clockwise here? UDL, is it clockwise?
Yes.
Now what about this 30 kilonewton? What about this reaction at D? So what about this clockwise? It's clockwise, huh? Anti-clockwise. So there are two anti-clockwise here, this and this, and there are, these two are clockwise. So now, so writing this, now when I take this, I should take this as minus 20 kilonewton meter into 1 meter, then plus this. Now this UDL, how do we handle?
10 into 2.
So the whole UDL has to be assumed to be placed at the center. So this is for every meter, but this it is for 2 meters. So it is 10 kilonewton per meter into 2 meters. So that is actually meter gets cancelled out. It becomes 20. Whole 20 kilonewton meter of force acting at a distance of 1 meter from B. From B it is 1 meter. So from B it is 1 meter. Okay, and then is it seen up to this point? Okay, and then what about this 30? Is it plus or minus?
Plus
30 kilonewton multiplied by 2 meters, and then now what about this? Is it seen? Okay, so minus RD into how much from this point? So 2 plus 1, 3. So 3 meter is equal to 0. What is the value of RD?
20 kilonewton.
It is? It is actually 20 kilonewton, the same answer as the previous one, because it made no difference. And then again, sigma F is equal to 0. That means forces going upwards is equal to forces going downwards. So forces going upwards are, supports are RB plus RD. Forces going downwards were actually 20 kilonewton plus 10 kilonewton meter for 2 meters spread and 30 kilonewton. So what is the value of RB? So RB is equal to 50 kilonewton. So you got the answer. So once you're done, then you replace this with these values here. So RB is equal to 50 here. So 50 kilonewton. Reaction at B is equal to 50 kilonewton. Reaction at B is equal to 20 kilonewtons. And then you need to draw SFD and BMD. So shear force and bending moment diagram. Last time we did not have UDL. It was straight lines. Now we'll have curves. Okay. So draw this zero line here. Zero line for SFD. And then you have to start from here. Okay, SFD at this point is how much? On the right hand side. As you come from this side, it starts from 0 kilonewton. But as you actually move across this point, then what's the value? You see a force, but you don't need distance because shear force is only the forces on right side and left side. Okay, some of the forces. So you don't need distance. So suddenly it goes from 0 to what value? That's minus 20. So the convention is this. So the convention here, you know that for a beam, anything on the right hand side downwards is positive. So it goes from 0 here, no forces on the right hand side, suddenly it goes to minus 20. It goes to minus 20 here. You don't have to write minus, why? Because it is below 0 line. As you move further here, there are no forces added. So it remains as 20 here. It remains as 20 kilonewton here. Now as you go further, as you go across this point, so it is, you are added with how much?
30 minus 20.
So 20 minus 20 plus 30, it becomes how much?
Plus 10.
It becomes plus 10. It goes to plus 10. Again, you will see that earlier, as you moved here, there are no forces. So it was a straight line. But now you see that as you move further, there are actually forces added here. I mean, it was a horizontal line earlier, but now you see an inclined line here. Because as you move further, more and more loads are added. So loads on the right hand side downwards is positive. So therefore you expect this to increase like this. Increase this, increase, and it becomes maximum here. So what is the value here? Basically, so suppose if you don't want to see on the right hand side, what you can see on the left hand side, you can start again from the left hand side if you don't want to see on the right hand side. How? So the left hand side going upwards is positive. So therefore if you see here, if you see this beam here, no forces, so you start from 0 here. And as you actually continue here, you shall suddenly see a force going downwards which is 20. So 20 going downwards on the left hand side is what? Positive, negative? Negative. It goes from 0 to 20 again here, very similar to the previous diagram. And then it again remains as minus 20 here throughout, because as you go from here to here, it remains same. And then, you know at this point, now as you go across this point, you will see minus 20 and plus 50. So what is the value?
Plus 30.
Plus 30. It goes from minus 20 to plus 30, it goes to this 30 here. 30 kilonewton. Now, you need to join this with a straight line here. You need to join this with a straight line here like this. So once you have done this, then you need to, because these lines that you have drawn may match with the ruled sheets of the answer booklets, so you make it dark so that those lines and these lines are distinguishable. Okay, something like this. And then, once you have drawn this, what is the next step?
BMD.
Draw BMD. So bending moment diagram, let us make some space for this, reference lines. So let us draw this bending moment diagram, 0 line. Okay. So from the previous diagram, you understand that left hand side has more shear stress. There's a huge change in the stresses here. So the left hand side is more critical. So now we are drawing the bending moment diagram. So this was SFD. So you can write it as SFD here. This is BMD. So you can write SFD right side or left side, whatever you want. This is free body diagram. This is SFD. This is BMD. Okay. Now what is the convention for BMD? For any beam which is like this, any forces up and upwards or both left and right makes it to sag, that's positive. So it is a section. So therefore, using the convention, we'll start calculating. So bending moment at D, what is the value? 0, because at this point there are no forces in the beam, so it is 0. But when I come here, bending moment at C,
20 kilonewton.
bending moment at C, so you see that there is a force which is going upwards. Is that positive?
Yes.
That's positive. 20 kilonewton into how much? 1 meter, that is 20 kilonewton meter, which is positive. So it goes from 0 to 0 kilonewton meter to 20 kilonewton meter, a straight line. It's positive. You can understand here. So in this beam, you can almost predict, I think by common sense, everybody knows. You may not know engineering this convention, but you know that this beam is going to bend like this. Again, this beam is going to bend like this. Okay. So from here to here, it is throughout sagging. Only from here it can actually start hogging. So here, wherever it is sagging here, sagging means what? It is not just below the line. Sagging means see the curvature. See the curvature of the beam. Here also it feels it is below the line, but you see that the change in shape. Now the shape is like this. Now the shape is like this. Here the shape is like this, and like this. You know the difference, no? Like this and like this. You see my shape of the hand like this. This is sagging. This is hogging here. Okay, somewhere it changes from sagging to hogging. You definitely expect some point of counterflexure here. Earlier it was easy because it was actually point loads. You could actually easily find out. Now it needs some effort. Okay. Now once you have done that, then you can, suppose if you don't want to mess yourself, you can start doing it on the left hand side. Left hand side, you see here, any forces on the left hand side? No forces, no distance. Definitely you will see that it is 0 kilonewton meter. And then as you come from here to here, how much is this? It is minus 20. So bending moment at B, it is actually minus 20 kilonewton meter into 1 meter. So sorry, B. So it is minus 20 kilonewton meter. So it goes from here, you see positive, you are seeing negative here, and you join with the line here. Okay, now you join with the line. Now here you see these 2 points. Here you see these 2 points. How does this vary? So basically this actually goes like this. It actually goes like this. So that means you need to know which is the maximum point here. Of course, here the shear force is not crossing this 0 line, somewhere in between. So therefore you will not have a maximum here. You will not have a maximum. Wherever the shear force changes from positive to negative, you can expect the maximum. So here you will see that the shear force is crossing exactly at this point itself. So therefore you can expect maximum here, and it will start going down like this. So you don't have to again find out this, it will start going directly like this. Okay? So you need to find out here. Of course, here the pattern at which it goes is not very clear. I think you don't have to worry. You just have to draw a line which is not straight. Okay? So we expect some graph like this. And also we need to know somewhere it crosses here. Now we also need to know that. So for that, how do we do it?
Triangle.
So here, suppose if it was a straight line, you could have made a triangle. It's not a triangle. It's a curve. So for that, what I will do is, I will assume that this point is at x, distance x. This point is at the distance x. And this point I will locate here, somewhere here. So which is again at a distance x here. Earlier we know that if you wanted to calculate bending moment at B was minus 20 into 1. Suppose if I wanted bending moment at xx, where you got this section xx, then you have to do some calculations here, extra calculations. So can we do that now? Okay, so now it has to be in terms of x here. So bending moment at xx is equal to, so can you help me now? Now the equation becomes complex because you are trying to take from here, and here you know the distance is x. So the force acting downwards on the left hand side, is it positive or negative? It is negative. It is minus 20 kilonewton meter into what distance? Is it 1 meter or 1 plus x? It is 1 plus x. It is 1 plus x meters. And again there is one, what is this load going upwards? 50 kilonewton. Is it plus or minus? It is plus 50 kilonewton into what distance? Into x meters. Okay, and then only two loads on the left hand side, huh? One this and one this. Now what about this UDL? UDL going down this. Going down, is it positive and negative? It is negative. So again, minus, now what is the intensity? 10. So 10 kilonewton into x meters. Acting at a distance of what? X by 2. X by 2 meters. Now this problem has turned a little complex, and this is where engineering students are challenged. Of course, if you practice once or twice, it becomes easy, but for the first time when you are solving it, it may feel difficult. So now you have seen an equation like this. So this is equal to 0. Okay, can we actually bring this into a readable form? I think basically this, we will try to reduce this multiplications and then bring it into a form. So I will can erase this. So can we write this equation again here? Bending moment at x bar x is equal to how much? So 20 kilonewton meter, because you can expand this 20 into 1, and then this is 20x kilonewton meter, and then what about this?
Minus 20.
So this is minus, sorry, these are two minus, sorry. It is the reason in examination you need to be alert. Even I did a mistake now, and you reminded me. There's nobody to remind in the examination. Okay, minus 20 and minus 20, and then this is plus 50 kilonewton meter. So 50x, sorry, basically 50x kilonewton meter. Okay, and then this is minus. So now what is this value? X into x square by 2. So if this 2 and this 10 cancels out, it becomes 5. So 5, it is 5 x square kilo Newton meter. Anyway, everything is in terms of kilonewton meter. This should be equal to 0. So you can now write this as, so which and all you can add? This converts into minus 20 kilonewton meter, minus 20 and plus, minus 20x and plus 50x. How much is this? Plus 30x kilonewton meter and minus. So of course, now this kilonewton meter can be taken outside. Okay, I'll write it and then remove it. And the 30x and minus 5x square. Kilonewton meter is equal to 0. And finally, this can be written as minus 20 plus 30x minus 5x square in terms of this is kilonewton meter. Okay, don't worry about the units, and finally you are ended up in this equation. I think you know how to solve this equation, no? A quadratic equation. So in calc itself we can solve. Okay, so please solve it in calc, quadratic equation. X is equal to
5.23 and 0.76.
x is equal to 5.23
and 0.76.
Guys, is this 5.23 feasible answer? X is, I think 5.23 is not a feasible answer. No, the other answer is?
0.76.
So, feasible answers are 0.76 is the feasible answer, because this x couldn't have been beyond 2 meters, because you wanted this x somewhere between 0 and 2. You understood what I am saying? One answer was out of the limits. What answer is 5.3. You can't have 5.3 because this from here to here itself is 2 meters. Okay, 5.23 you neglect, and the other answer is 0.76 meters. Now, if you want, you can check this. Of course, it is the calculator is given, that means it's right. If you substitute this, I think it should give 0. Okay, I think people earlier were trying to do with algebraic equations, x square plus bx plus c. At that time, people used to substitute this and again check whether the answer is right or wrong. So now we can definitely check. Substituting this, it is 0. Please check by substituting this. Substitute this value and check. Minus 20 plus 30 into 0.76 is 2. 30 into 0.76 is 2. Okay, yesterday 30 into 0.7. 22.8. And so 0.76 square into x. So you should get 2.28, which is this value here. ಇಲ್ಲಿ 20 ಇದೆ, plus 2.28 get added, so you have to deduct this 2.28. So this becomes 0. Here it is plus 22, extra 22, which becomes plus 22, and 2.28, which is equal to 0. Obviously, by substituting this, you are getting 0, which means the answer that you got is right. Okay, so this point x is equal to 0.76 is the point of contraflucture. Because the point of contraflucture where the bending moment changes from positive to negative. And this doesn't go beyond this point, it will go like this. Guys, what is the bending moment at this point? 20 kilonewton meter. Here it is 20 kilonewton meter. Guys, I said earlier, if you don't want to do this, you can actually check this. Once you have done this, if you want to confirm that the answer is right, you just check this, like the area. You please check with the area of this. So please shade this value. You can first don't draw this with dotted lines, guys. You can actually make this thick line itself like this. Guys, you can make it just thick line itself here. Now we shade this. Okay. Guys, how do you check these answers? Here you see the area here, no area for the shear force. Here if you see the area, what is the length here? 1 meter. 1 meter into 20. It becomes 20 here. Now it is actually minus 20. As you go further, you will see area getting added which is positive. Area which is getting added which is positive, that means this minus starts again going upwards like this. Okay. And therefore you see at some point this area and this area becomes equal. At that point it becomes 0. Now this area below the line and above the line becomes equal. At that point bending moment becomes 0. And again when this area starts getting added, it starts going like this. It becomes maximum here. And again when it starts becoming minus, you will again start to see going downwards. Okay, so like this you can expect somewhere here. This area minus this area, minus and plus, it becomes 0 here at this point. And further, this values will try to increase this and it becomes up to 20 here. And again from here you will see that it is minus, it starts getting decreased like this. You can actually, seeing this and seeing this, you can see whether the answer is right or wrong. Please check this. For actually few seconds you can check the answer, which will ensure you 12 to 15 marks.